All right, so now that we've done a little bit of review, let's get into our rational expressions. So remember that rational expressions, it has the term ratio right there in it, and a ratio is a fraction. So these are expressions whose numerator and denominator are going to be non-zero polynomials. So remember we learned about polynomials last 6 weeks. The domain, the x values, have some excluded values, and we'll talk about those restrictions or excluded values in more detail here in a minute. But the reason that that happens is if we have a polynomial in the bottom and we set it up to where x is a value that makes the denominator 0, well, then our expression is suddenly undefined because we can't have a 0 in the denominator of a fraction. So we don't ever want the denominator to be 0. Finally, we will be finished with simplifying a rational expression if we don't have any common factors left, so no common factors. Let's go ahead and talk about these excluded values, or another word for those is restrictions. And let's talk about why we have restrictions. I mentioned it briefly there, but basically when we eliminate a variable from the denominator of a fraction, remember now we're working with polynomials, so it's not just numbers like we had before, we're going to have variables as well. If we eliminate that through simplifying, then we need to be sure that we account for the fact that the original fraction still has to make sense. It can't have a 0 in the denominator because that would be undefined. You'll see this a little more clearly as we go through some examples. So our first example, what we want to look at is our rational expression, and we want to find any factors that the numerator and denominator have in common. Now for this one, I set it up to kind of ease us into this, and we are already factored. In other words, I have a linear term here and here and here, and every single term is being multiplied together. So I just want to look for things that the numerator and denominator have in common, and I see that I have an x plus 1 in the top and the bottom. So I'm going to cross out x plus 1 in the top and the bottom, and that's going to leave me with a simplified form in the form of 2 and an x plus 3. But now let's talk about what we got rid of here. We got rid of an x plus 1. And so we no longer see that in our final form of our answer, x plus 1. But we know that denominators can never equal 0. So even though we don't see that anymore, it got eliminated with our simplified form, we need to say that that factor we factored out can't equal 0. So x plus 1 cannot equal 0. And in order to solve for what x is, I need to subtract 1 from both sides. So x cannot equal -1. And that is actually part of your answer. You have to report that or it's not a complete answer. Let's look at the next one. The bottom is already factored, but the top needs to be factored. And since that is a quadratic, we will use our x box. So let's go ahead and do that. So we need to do x box to factor. I'm going to use pink to come down here and factor this. So everything that I'm doing right now is to factor this expression. Remember our x box. We want to do a box. I'm going to have a negative, this should be a -12. Sorry about that. Yours will have a 12 there. I am not sure what happened to mine. So 1 times -12 is -12. This will be a -4. And I want to figure out what two things will multiply to be -12 and add to be -4. My bigger number needs to be negative, so I'm going to say 1 and -12, 2 and -6, 3, and negative 4. Let's take that over to a box with x squared here, minus 12 here, and I need, let's see, 2 and negative 6. So 2x and negative 6x, and I'll have x as a GCF, 2 as a GCF, x as a GCF, negative 6 as a GCF. So I can rewrite as x minus 6 and x plus 2. Now remember, all of that work was done to factor the top. The bottom is already factored, so I'm going to rewrite all of this, but replacing this original trinomial with the factored form. So let's do that. X minus 6 times x plus 2. The pink is the top that I just worked on. And then I didn't have to do anything to the bottom. It was already factored for me for this one. So let's go ahead and see what we can cross out. I see an x plus 2 in the top and bottom. Remember, anything divided by itself is 1, so we can cancel those out and say that it's equal to a 1. And so we have x minus 6 over x minus 2 left, and that is our answer, but now we need to look at restrictions. I crossed out just now an x plus 2, so I need to account for that in my final answer. I'll say x plus 2 can't equal 0, subtract 2 from both sides to get x cannot equal negative 2, and that's part of my final answer.